Okay, we'll give it a few minutes here for people to trickle in and get the tech set up and audio working.
We just wanted to welcome everybody while we're waiting. Thank you so much for taking some time out of your day to join us today. We know you have a lot of things going on. You have a lot of things that you could be doing, but you chose to spend it with Michael and I today, and we are super grateful. I think we're going to have a little bit of fun, I think, probably. Um, and I'm excited to do that. Go ahead and get settled. We'll be starting here in just a moment.
I will go ahead and move us on to the intro slide. Ta-da! We'll start with you.
All right. Hello. My parents named me Katie Walker. Let me tell you a little bit about myself. I am the IT support lead at CrashPlan. At CrashPlan, we provide a peace of mind through secure, scalable, and straightforward endpoint data backup. You can hear more about CrashPlan later if you'd like. Otherwise, it's weird to say that for me personally, I have been in the customer service and IT world for 15 years, and that is just really ridiculous to me. But here we are. And in my picture that you see on the screen is my favorite being in the entire universe. That is Scout. He is wonderful. He is my exact mirror. He is that dog. He is my soul dog, and he deserves a shout out whenever I talk about anything. Anyway, over to you, Michael.
All right.
What do you got for us?
I unfortunately do not have a doggo, otherwise, I would shout them out. My name is Michael Belleroux. I am sales tech here at Nagios Enterprises, also known as the Hawaiian Shirt Guy. At Nagios here, we make monitoring software. A lot of what we'll talk about here is probably best monitored with our product Nagios XI, which is kind of your relative. No, I hesitate to call it a standard network performance monitoring tool because people come to us and say, "You can monitor that?" And I'm like, yeah, we can monitor that. So, anyways, we make network performance monitoring tools. A lot of good stuff. If you want to learn more about us, hit us up on our websites and our socials. Make sure to smash that like and subscribe button. Oh, God.
Yes. Yes, Michael.
Okay, I'm back.
Do that for CrashPlan too.
Okay.
I'm just gonna do that for CrashPlan too. So what are we actually here for today? We are going to talk a little bit about endpoints. We're going to talk a little bit about monitoring, signs for failure of endpoints. We'll say hard drives, to be perfectly honest, a little more specific about hard drives. Um, Maybe there's a way to have a proactive replacement solution in line for when your hard drive is going to fail. So, because we already know it's going to fail, we're going to talk about what might you be able to do about that. And we hope that you gain a little bit of knowledge. I hope you have a little bit of fun with us. And as that goes, let's get into it. The first thing that we'd like to talk about with everybody to do with endpoints and more specifically, their hard drives. What's the deal with hard drives? Do they even drive? No, they don't. But let's not talk about what they don't do. Let's talk about what they do. What they do is hold every important piece of information in your life, likely personal, professional, whatever you think. And I know what you're thinking, Katie. You have been in tech for 15 years. You just told me that. Everything is in the cloud. Why do we even have to worry about hard drives? They're going to fail. It doesn't matter. It's in the cloud, right? Well, you're not wrong. Cloud backups are super affordable. They make doing a backup super accessible, way easy to manage for my fellow IT departments out there. Super good. but it's not a backup. It might have certain files that the end user decided to put there, but that's not a full backup. So it's important to remember that that full backup is actually a computer somewhere else holding your cloud storage. We're not going to get into that, but you get what I mean. No matter what form of backup that your company decides to use, everyone still needs an actual endpoint to perform their job as successfully as they can. And by endpoint, even in talking about computers versus tablets versus mobile devices, whatever, some sort of medium needs to be there. Endpoints are still the best way to go, I would assume. Um, and that endpoints technology needs to keep up with the technology of hard drives. So really, the endpoint is more important than ever before. The other technology inside the computer needs to be able to support that hard drive. It needs to be able to keep your data safe, keep the computer running correctly with all this new speeds and weird glitches and what have you. That endpoint is really, really, really important. And as an IT professional, I can definitely say with some confidence that employees definitely care about what they're getting for endpoints for their computer for their job. Excuse me. They're very aware of what's going on and what makes their daily life easier or not easier. And I get asked quite a few times, "Is it going to be the same? Is it going to be different? Can I have a new one? How about the newest model? How about that new M2 Apple?" All of that. Therefore, I'm thinking that the endpoints are more of the thriving medium than an actual ancient tech. They're very, very important to everything that we do here in the business world, as well as in our personal lives, probably, I would guess. Um, Michael, I know you had some interesting thoughts on the actual stats on some hard drive usage, lifespan, failure rates, things like that. And lucky enough, you're right here. Could
Here
you
I
tell
am.
us some some things about that?
Sure. Yeah. So hard drives. When hard drives fail to live up to expectations. So we've all seen the stats for spinning rust drives. The brand name of drive that you bought might not be as solid as you thought it was. But also, like, hard drives just fail. It's what they do. That's going to happen. There are spinning parts in there. They're going to crash. Monitoring your drives could be the difference between changing out a drive as part of routine maintenance, or sending someone out in a panic to try and get an executive ready for a meeting that they're going to have in the next 10 minutes, and they just called you because they can't access any of their files. So aside from just whether or not a hard drive is dead, there's also performance. There are a lot of acronyms out there. There's SMR drives, there's CMR drives, there's SSDs, HDDs, NVMEs, all kinds of things. What ends up happening is if you give a user the wrong drive, they're going to say that dreaded phrase of "it's slow." And well, what do you mean by slow? And it's irksome for the user to hear, what do you mean by slow? But we kind of need metrics to go off of. Otherwise, we're going to be troubleshooting something, you know, forever essentially. But one of the things you can do is you can put a number to that. You can monitor these hard drives and say, just check in every 5 minutes and show me the number of IOPS going through here at this time, or megabytes read, megabytes write, that sort of thing. And that's all part of kind of a larger discussion around finding out what is normal for your environment that we'll definitely be getting into later. But for right now, you're probably looking at me going like, what the heck, Mike? You're talking about hard drives. Everyone's using SSDs now, bare minimum, if not NVMEs. SSDs also have their own issues too, starting with the 80% utilization. If you move beyond 80% utilization on a solid state drive, you're going to have a bad time. That's going to get real slow real quick. There's also a bunch of alphabet soup with relation to solid state drives. There's SLC, MLC, TLC, QLC. Why are these LCs even? um, there's drive flags. Of when a drive might be failing. We'll definitely talk about those. Those are the smart monitoring settings. There is the wear level on solid state drives, and if you're not monitoring that wear level, it will fail at the least convenient time. Murphy will make sure of it. And then there's NVMEs. NVMEs, stupid fast, but also if you put the wrong workload on them, they can get really hot. And oftentimes there's really no there's no kind of heat mitigation on those NVMe drives, like heat sinks or anything like that. And oftentimes they're just kind of crammed into a laptop wherever they'll fit. And so if you put the wrong workload on them, they heat up and then they're just like, nope, magic smoke, go poof. So watch out for that. NVMEs also have a wear rate on them, just like SSDs. So make sure you keep an eye on that. Katie, you want to take a crack at some of these acronyms I'm just tossing out?
Yes, I would, Michael. Uh, yeah. So to sum up a bit, um, SSDs versus HDD, solid state drive versus hard disk drive. What are you choosing for your environment? Is there a better one than the other one? Or NVMEs, to be honest. Let's not forget them. Um, well, as you can see, just a few bullet points kind of give us the main differences, we'll say, from HDD to SSD. So, as Michael was saying, a hard disk drive is going to have moving parts. Because of those moving parts, they become a little more vulnerable to physical damage. If you're picking up your laptop by your one hand and shaking it around, and you've got a spinning part in there whilst it's on, it gets dizzy. We'll just say it gets dizzy. And anything that gets dizzy isn't going to probably work in the way that you're hoping. Anyway, on the nice side, hard disk drives, those spinning hard drives are pretty inexpensive now. So they are cost saving if you're looking for something like that. They do also provide some indications of failure that don't require technical monitoring, other than maybe having the ability to hear or see or touch. You can kind of hear that click noise of a failing hard drive. You can feel also the spinning not quite moving like it should, if you know where that lives in the computer. So that's actually kind of nice. On the flip side, that solid state drive doesn't have any moving parts, so everything that I was talking about over there, moot. It can hold information without any power, which is kind of a superpower, not gonna lie. So that might give a little up point to the solid state drive. It potentially has that longer lifespan because it's not quite as vulnerable to physical damage. So there's a little less factor there. And then there's no indication likely that your solid state drive is going to tell you that it's having a problem. It's just going to one day, like that's it. Uh, what we can know from all of what we've just been talking about, that both hard drives, hard disk drives, and solid state drives can have bad sectors and lead to data loss. But it only takes a small percentage of those sectors to be bad to actually make the drive inaccessible. So, from what I just mentioned, then again, it sounds like both hard disk drives, solid state drives have inevitable failure in their DNA. And I'm hoping that Michael has actual advice on what people can do to maybe keep a really good pulse on how their hard drives are doing. Hopefully, maybe a little bit of relief, Michael.
Absolutely. I got some smart things you can monitor here. So for those not in the know, SMART stands for self-monitoring, analysis, and reporting technology. And there are a bunch of metrics that that SMART records, and Google put out some research here. I'll probably I don't think we have the link here, but we can definitely send that out in the follow up after the webinar here. But Google put out some research from based on their data centers, and they found some points that are more likely to be useful to determine whether or not a drive is going to fail. So starting off with offline uncorrectable sector count, attribute number 198 or 0C6 for those of us who like to count in hex. So drives deal with uncorrectable sectors fairly gracefully, but there are limits. So this is basically the drive encountered a sector that was unable to be corrected. This is now a bad sector. It's gone. Let her go. Reallocation event count, attribute number 196. Pretty much basically what it says on the tin here, a count of the successful and unsuccessful attempts to transfer data from a bad sector to a spare, hopefully good sector. Yeah, hopefully a good sector, because we're trying to save that data. Reallocated sector count, attribute number 5. This is slightly different from the previous one. This records the successful reallocation of sectors. Is there a difference between this count and the previous count? If there is, there's a little bit of wiggle room, but generally that probably means that your hard drive is on its last legs. Current pending sector count, attribute number 197. This can be a tricky one. Sometimes drives just wait to remap sectors. And sometimes drives run into problems remapping sectors. This count can be indicative of either of those situations. So unlike other smart metrics, this metric can grow and it can shrink. If you're just looking at this metric right now, it might be 0, but 5 minutes ago, it may have been 3. Who knows? Are you monitoring it? Should be. And that's where a lot of like the historical graphs are going to come into play. If you're monitoring it every X number of minutes, you're going to know, 5 minutes ago, this count was at 10. And now you're monitoring it now, and now it's at 7. So it's going down. That means it may have just taken some time to remap the sectors. If it stays, at that 7 mark or at another level, it could mean that it doesn't really have a place to send those the data from those bad sectors, and you're kind of in danger of losing it. So watch out for that. And then, unfortunately, there will always be random failure. Sad face. So while it's awesome to have these studies that show us, these points of correlation, correlation does not always equal causation. So Google found that about 36% of the drives that failed to record any smart data. So yeah, that's a pretty good chunk of unexpected failures there. Definitely worth monitoring things. But yeah, those are the smart things to monitor. But what to expect when you're not expecting drive failure? So I don't know. A lot of people hate me when I talk about this, but you can do things like look at the number of employees in your office with some back of the napkin math. How much money do you think would be wasted if a critical server wasn't able to perform its duties because of a dead drive? we're talking mainly about endpoints here. So reeling it back to, you know, endpoints, laptops, workstations, that sort of thing. If you get a sign that a drive is failing, you get to provision a new drive for the user, and you know, while that user is still able to work, and then schedule time with them to replace the drive. Then they know that it's coming. They can prepare accordingly. If you weren't proactive about this, you know, you would likely have to reschedule a meeting with someone outside the company. I'm sure if that would probably be like the worst time for it to fail. It's like, oh, I gotta go off site and meet with this customer or something, and no, you don't. Now you got to go back into the office and get a new hard drive. So ultimately, the point is we want to minimize the impact from hardware that we know will fail. You know, there's always going to be, you know, in the case of that Google study, there's always going to be that 36% of failures that just come out of nowhere. But instead of just giving up and saying, oh, well, we're going to have unexpected failures, you don't have to add expected failures into your unexpected failures. So monitor things. Tell your friends.
Well said, I'd say.
Thank you.
Well, since you're going to monitor it and you're going to monitor when they inevitably fail, you're going to see it, hopefully. Luckily, cloud backups actually make migrating data pretty easy. As I was saying before, the cloud definitely has its place. There's nothing wrong with the cloud. There's a lot of good, wonderful things about the cloud, including this. And in order to make sure that all of those cloud backups are doing what they're supposed to be doing, it's a really good idea to have regular test restoring of your backup. Regularly you know what I mean. Do it regularly for restoring your backup. Make sure it's there. You might be able to see in a console or something, some percentage that says, yeah, you've got, you know, all of this data backed up. But that doesn't mean other things, because the world is out to get us. Other things happen too. Maybe the backup doesn't work. Maybe it's corrupt and you didn't know that until you tried to put it back onto a new device. 41% of UK companies have failed to test their disaster recovery systems within the past 6 months, or don't remember when that testing took place. We'll get a link for that resource, but that is a big percentage, I'd say, of companies that have actually failed to test their recovery at all. I am definitely in the mix of forgetting that it's important. I definitely fall into the trap of the cloud backups are a set it and forget it kind of thing. They're not. They have worked really well for us. So I think we've been a little bit trained to think that they're most of the time they're pretty good, and most of the time they are. But you should still test it just in case. Trust but verify.
Mhm.
Um,
An untested backup is just wishful thinking.
Yes, yes, exactly. That is exactly what I think. Um,
This is fine.
just, yep, this
Yep.
is exactly what's fine.
So yeah, shit happens. Anything that you know, physically breaks your computer, you know, fires, hurricanes, melted chocolate bars, cats running over your computer with a car, um, throwing your laptop out a window. Who knows? You know, we get frustrated. Whatever. Um, but we also wanted to kind of touch on cybercrime a little bit here too, because a lot of what we're talking about isn't necessarily like hard drive failure. The key problem is going to be data loss, and that's the scary part, right? We don't want to lose data. That's bad. Ransomware, kind of the big dog in the cybersecurity realm for the last decade or so. Is all hopeless in the face of ransomware? Probably not. People often feel hopeless when thinking about ransomware because you've got all these groups who are like, we're going to write malware. It's going to evade detection by all these different multi-billion-dollar companies. And, here we are, just a small fish in a big pond. Isn't that good enough? Well, not really. So small fish in a big pond is not the best metaphor here, because small companies can get hit by ransomware just like larger companies. You don't get to hide in a big pond because we're all connected to the same internet. But I'll tell you a secret. You can often spot ransomware if you know what you're looking for. So how do we spot ransomware? Well, no matter the programming language, no matter the origin of the ransomware itself, all ransomware wants to encrypt your data. That's just what ransomware does. But is that an invisible process? No. So disk activity is going to be the key metric here. So what you need to do is you need to find out what normal looks like for your company, for your servers, for your endpoints, during business hours, during off hours. If you find out what normal looks like, then you have a good shot at detecting malware, whether that's malware from 10 years ago or the very latest strain of malware. And this is a hard one for malware authors to deal with, because they basically have two options if you're monitoring your disks like this. They either encrypt your data as fast as they possibly can, and if you're monitoring the disks, your monitoring system, that just looks like someone shot up a flare to your monitoring system. The other alternative is they linger in your environment and find out what normal looks like for your environment and encrypt your data within the realm of what's normal for your environment. That's a really very not good option for them, because that increases the code complexity for their malware, and it increases the linger time, which greatly increases the chance that they're going to get caught. So neither of these options are particularly good. Other metrics that you can monitor to help defend yourself is making sure that your anti-malware service is running, like Windows Defender. Make sure that that's still running. You can also probably monitor an exceptions list. So if someone starts adding exceptions to your anti-malware software, you want that to throw up a red flag. Network traffic can be a good one to monitor as well. In the case of 2 or 3 phase ransomware, the second phase in both of those is always going to be extracting data to potentially blackmail the victim. So again, find out what normal traffic looks like for your business, and find out why your strict 9-to-5 office is transferring gigs of data at 2 in the morning. So
Completely normal.
Yeah, this is fine. So we've spotted the ransomware. Now, how do we stop it? Well, Nagios Core and XI have features called event handlers, and event handlers can be programmed to take action when certain events happen. So like someone shuts off Windows Defender, you can have an event handler that just turns that back on. Being someone who has messed around with live viruses and test environments, it can be really irritating when Windows Defender comes back on, because it just doesn't ask you. It's like, hey, I know that's a virus. You're gone. So that could be very annoying for an attacker. But you could take that to the extreme and even shut down your systems if you wanted to. So you can go from something very basic, like just turning Windows Defender back on, and just leave it there if you like. Outside of Nagios specific monitoring, any monitoring tool should be able to give you that heads up about the metrics that we talked about and give you prompt notification. The difference here is going to be getting in touch with the user within 5 or 10 minutes of detection versus only finding out about the possible infection after the user's entire drive has been encrypted. So I know this slide is a little silly. I started going on different ways to fill out those 4 letters, and it just didn't work. But seriously, I want to make sure everyone knows, don't pay the ransom. If you get hit with ransomware, don't pay the ransom. It's a bad idea. if you can avoid it, rely on your backups, rely on early detection. Katie, I'll let you take this on the next slide here. Paying ransom is bad.
Ransom, paying, bad. Criminals, bad. Uh, so as Michael was saying, ransomware, there are ways not necessarily around it, but if you're monitoring and you're paying attention, there are ways that you can, lessen that blow a little bit. So it's important with all of those monitoring tools that you have, take stock of what's actually been compromised. Take a look and actually pick out the things that aren't right, so we know exactly what to take away to make everything work again or what have you. Um, this is also where that handy cloud backup really, 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 really helps. So that way, even if they encrypt all your data, you shut that thing down, you go to a different point in history on your backup from before the ransomware got on the computer at all, and then it's done. I mean, there's not really much else you as an end user need to worry about. You just thwarted their plan. And again, because we can't say it enough, don't pay the ransom. According to the FBI, who I hear we should listen to most of the time, they say that paying a ransom doesn't guarantee you or your organization will get any data back. It also encourages perpetrators to target more victims and offers an incentive for others to get involved in this legal or type of illegal activity, which I think makes sense, really, when you think about it. I feel like we've talked about a good amount of things.
Mm-hmm.
I feel like we got to the point where we can conclude, maybe.
That's
We
good
kind of
because
went
that's
full
the next
circle.
slide.
Oh, thank goodness. Okay, good. I think it really, yeah, what it all comes down to is really simple. Monitor your shit and test those backups.
Mm-hmm.
That's what we got.
I like your quote here. Data issues are inevitable, but data loss doesn't have to be.
You're right. It doesn't.
Mm-hmm.
And I hope that Michael and I have led everybody listening to some conclusions. I hope it made you ask some questions in your brain, like, do Michael or Katie know what they're talking about? Yes, a little.
Let's not
Some,
ask these
like
questions. Let's
like a little bit like that. Uh but we're happy to answer any questions that you all may have after listening to us for a little while.
Sorry. I forgot to hit
You're
the
good.
button. We're
All
professionals.
good. We are the best ones.
That's right. Thank you for
That
joining us.
yes, thank you very much. From CrashPlan, you can see our website on there if you want to know more about the company. Nagios, Michael, they should probably go to that website, I would say, right?
It's a website. It's a good web. Yeah. And
Okay,
CrashPlan's good.
yeah, great.
And we can test
Great.
things, test our
Everybody,
backups,
yeah,
test our
test
monitoring.
your backups, test everything, monitor everything. Make sure to take breaks, though. It's okay to take a break professionally. Go get some coffee. Take your dog for a walk.
Coffee.
It just all works out eventually. Work hard, but not too hard. But
Right.
really work hard. Okay, anyway, I'm done.
All right. Thank you, everyone.
Everybody have a wonderful evening, day, life.